Okay, let's do a couple more product rule and quotient rule. And let's do some funky looking exponents here, just so we can get some practice with them. Okay, so I've got a product of functions here. That's the first thing I want to notice. Big picture, I've got one thing times another. I'm going to need product rule. So let's call this guy number 1 and this one number 2. So then the derivative is going to be derivative of the first, leave the second alone, plus derivative of the second times leave the first alone. And we could do these each separately. And since this guy's going to be funky, maybe we should. Maybe we should do these one at a time. So the first guy is derivative. Look in here. I'm going to have 2 times 8, 16, x to the first power. 2 minus 1 is 1. Plus, the derivative of 9x is just 9. And then here, I got to use power rule. I've got this weird exponent, 2/3. 2/3 times 1 is 2/3. The x comes along, and now I'm going to have up here 2/3 minus 1. So I got to think now, what is 2/3 minus 1? That would be 2/3 minus 3/3. That would be negative 1/3. So this would be 16x plus 9 plus 2/3. And I could write that as x to the negative 1/3. Or if I wanted, I could bring that x down into my denominator here and make that power a positive. Either way is fine. I'm going to write it like this, but it doesn't matter. Okay, what about number 2's derivative? I've got 3 over x. 3 over x, I could do quotient rule on, or I could think of this as 3 times x to the negative 1 power. Then his derivative, I just use power rule. Negative 1 times 3 would be negative 3 x to the negative 1 minus 1. So negative 3 times x to the negative 2. Then I'm going to write negative 3 over x squared. Similarly, this guy here, I'm going to rewrite as 5x to the negative 4, and then take his derivative. Power rule was always easier than quotient rule when you can use it instead. Negative 4 times 5 would be negative 20. X, negative 4 minus 1, you got to be careful here, is negative 5. So I'm going to write that as minus 20 over x to the 5th. Okay, now we got our pieces set up. So h prime will be derivative of the first, this stuff right here. Times the second. Leave the second alone. Second was 3 over x minus 5 over x to the 4th. And I've run out of room there. Plus, this should ideally all be on one line. Derivative of the second, negative 3 over x squared minus 20 over x to the 5th, times, leave the first alone. And notice all my parentheses here. These are all required. If you don't write these parentheses, you're going to get the wrong answer. Okay, last problem today. Let's do a quotient rule problem. So I've got a top and a bottom. We'll call those number 1 and number 2. The derivative of a fraction is derivative of the top leave the bottom alone, minus derivative of the bottom, leave the top alone, over the bottom squared. And I'm not going to write each one individually. We're just going to do this as we go. And K prime will be derivative of the top. So this guy here, that's a power rule. I'm going to get 4/5 times X to the, what's 4/5 minus 1? So we'll do a little side work over here. 4/5 minus 1 would be 4/5 minus 5/5. That's negative 1/5. Minus 8 times 1.3. So that would be, let's see, 80 plus 24. I think that's 10.4 times X to the 1.3 minus 1 would just be 0.3. Definitely check my arithmetic on that number. I just did that in my head. That's the derivative of the top. Times, leave the bottom alone. Minus derivative of the bottom. 9 times 5 is 45. X to the 8th. Minus 0, the derivative of a constant is just 0. Times, leave the top alone. Trying to fit this in. Minus 8x to the 1.3. All over the bottom squared. And then I'm sure this could be cleaned up. I don't think it's going to look any prettier, but maybe it could be cleaned up a little bit. Okay, and that's a good place to stop.